Welcome to another video in physics. In this video, we're going to be discussing Newton's third law. For every action, there's an opposite and equal reaction. Well, as I get started, let me let you know that in this video, we're going to be discussing Newton's third law using three examples. Number one, this football hit that you just witnessed. Number two, a rocket ship taking off. And number three, recoil. So these three examples show us Newton's third law in action in real life scenarios. So here you have a runner with a ball. He has a force, he has a mass and an acceleration, and you're going to see another runner who must have the same force. Bam, right there. Now the reason we know that he must have had the same force is because they both come to a dead stop. That must mean that the tackler, the one in white, matched the force of the one in blue. That's Newton's third law. Now here's the thing that the tackler, the guy in the white, right there, the guy in the white must have forgotten, because he's about to lay a hit on this very large football player. He's about to lay down a hit. But what he doesn't realize is that the force that he applies on him is going to come back. The force that he's going to apply on the football player with the blue jersey is going to come back to him as well. According to Newton's third law, for every action, there's an opposite and equal reaction. So both players were knocked out. So for every action, there's an opposite and equal reaction. So they both must have been carrying the same amount of force. And we know this because they were both stopped cold. It's like they might as well have run into a brick wall. Because when you run into a brick wall, when you hit a wall, whether you run into it or you punch it or whatever the case may be, so just imagine yourself punching a brick wall. What's the sensation you're going to feel on your fist? It's going to be pain. Or you might even break your arm or your hand. Because the amount of force that you apply to a wall, there's going to be an opposite reaction. There's going to be a reaction in the opposite direction on your fist. And you're going to feel that in the sensation of pain. So it's almost like the wall has a mind of its own and it's hitting you back. But in reality, you're hitting it and you're just getting the same force in the opposite direction. So in this case, the football player tackles the one in the white jersey, tackles the one in the blue jersey with an enormous amount of force, but because the player in the blue is so large and he also has a force that most likely matched his own, they were both knocked out. It's like they both hit a wall, and that was it. So even if you're the aggressor in tackling, you must always brace yourself because of Newton's third law, because you also will feel the impact of your hit. Now, of course, for those who know that it's coming, it comes as an advantage because, well, you know it's coming. Okay, well, let's move on to our next illustration, and that's the rocket ship. Here you're going to see an action. You're going to see the thrust from the engines push down. So that thrust, that initial action of pushing down is going to cause an opposite reaction, pushing the rocket up. So now the rocket goes up because of the Newton's third law. So it's a very basic principle that's applied in extraordinary ways here, especially when it comes to rocketry, because again, the thrust is pushing down, causing the rocket to go up. That is the opposite and equal reaction. Now, of course, the thrust must be strong enough to overcome the mass of the rocket ship itself. Otherwise, if it matches the amount of mass of the rocket's not really going to go up. So here I have some extra footage for you showing a rocket ship taking off from the perspective of somebody sitting in an airplane. So somebody flying in an airplane was basically got an awesome seat. They were at the right time, right place at the right time, and they got to see a rocket take off and go out into space. So this rocket by now probably has hit the sound barrier, and they're escaping the Earth's atmosphere and going off into space. I thought that was pretty cool, so I thought I would share this. And again, illustrating Newton's third law, for every action, there's an opposite and equal reaction. The rocket thrust pushes down, the rocket goes up. Pretty cool. So in my third illustration here, we're going to discuss recoil. Primary recoil when a gun is fired is the bullet, the gas in the bullet, that the gas that's created by the bullet being fired expands and it pushes the bullet out. Now secondary recoil you're going to see here, the bullet, as a bullet shoots out, you'll notice that it's going in the forward direction. So that's the force going out. The opposite and equal force is going to be the gun being recoiled back. So that's recoil. So the bullet goes in one direction, that's the action, and then the reaction is the gun going back, recoil. And here you're going to see it again. The gun gets pulled back, recoil. Now, so in this case you have a young lady holding up, looks like a pretty powerful gun, and she is not prepared, obviously, for the recoil that's about to happen. And you're going to see this because, well, here goes. Yep, she did not understand Newton's third law, that when an action occurs, there's going to be an opposite and equal reaction. And in this case, it's the recoil of the gun. Boom, right there. Okay, well, that does it for this video. Again, this was Newton's third law, and we used 3 examples. We used a football player, the rocket ship, and the recoil of a firearm to illustrate Newton's third law. So forces always come in pairs. You have an acting force, and then you have a reaction force that is in the opposite direction of the acting force. So for every action, there's an opposite and equal reaction. Thanks for watching, and good luck in your studying.